Welcome to another Paper Classroom 5-minute tutorial for the Level 3 Technical Certificate in Paper Making. In this session we're going to talk about fibre dispersion. Particularly we'll be talking about the Hydra Pulper. Here's a typical high consistency Hydra Pulper. As you can see, it's got a high profile rotor. That makes it easy to remember. A low consistency Hydra Pulper has a low profile rotor. One thing I always like to talk about in the beginning of these sessions is the fact that it is a Hydra Pulper. Everybody is lazy, no one likes to use big words, they can use small words. And so many people refer to it as a pulper. And those that don't know, because they're then taking sheets of pulp and throwing them in a pulper, they believe they are pulping. Not true. Pulping is the act of taking a whole plant, like a tree, and reducing it into individual fibres. What we're doing in this equipment is not pulping, it's dispersing. We're simply taking the sheets of paper pulp that we're given and dispersing all the individual fibres ready to do some work on them. Hydra pulpers have a variety of different designs. At the one extreme we have high consistency pulpers, at the other extreme we have low consistency pulpers, and in between we have medium consistency pulpers. In this section we're only going to be talking about the two extremes really. So there are pulpers with top entry rotors. They're not very powerful, they can't break down very much fibre because it's going to be a really easy to break down furnish. Bottom entry rotors are by far the most common. We also have Hydra pulpers with side entry rotors, particularly useful if you're in a confined space, if you don't have a lot of headroom. And finally, there are such things called high-low pulpers. High-low pulpers used to have two different rotors, a high consistency version and a low consistency version, and it could operate in either mode. Very rare, you don't see those these days. Low consistency pulpers, all pulpers have got both advantages and disadvantages, and that's the point of this session really, to be aware of the differences between high and low pulpers. So the advantages of low consistency pulping is the fact that you can operate it in continuous mode. You can feed in pulp and water and you can continuously draw out dispersed fibres. The other advantage is because it's so very, very aggressive, it will break down papers containing wet strength. However, the disadvantages, in my opinion, outweigh the advantages. It's not very power efficient. These things operate typically between 4 and 6% consistency. And if you're operating at 4% consistency, that means for every 4 grams of fibre, you're moving around 96 grams of water. So not very much of that electricity that you're paying for is going into the fibre itself. It's all been spent just turning water around. Also, because it's so aggressive, it damages fibres. And by damaging fibres, it can snap them in half, it could break the ends off, but essentially it's reducing fibre length. And by reducing fibre length, we can then have fewer fibre-fibre crossovers, which means we'll have a weaker sheet. And if it's breaking the ends of fibres, then effectively we're creating fines. And fines are going to block up the sheet, they're going to block up the sheet on the wire, it's going to reduce drainage, so it's going to go through the wire and we'll have losses, so fines are not very good. High consistency pulpers, the advantages and disadvantages are almost the opposite. So for example, they are very power efficient. High consistency pulpers operate 15 up to 40% consistency. So at 40% consistency, a lot of that electricity is being used to do work on the fibres, so it's much more power efficient. These things travel around a lot slower, but with a lot more torque, and therefore they're nowhere near as aggressive as the low consistency pulper. Because they're not as aggressive, they will not damage your fibres. Fibres are much less likely to be snapped in two or for the ends to be ripped off. Therefore you'll retain a longer fibre length, which means more fibre-fibre crossovers, therefore a stronger sheet of paper. Because you're not snapping fibres, you're not producing fines, and also because that concentration is so high of fibres, they will rub against each other. You will start to produce external fibrillation. So you're starting to do part of the refining process while you're still dispersing your fibres. And the disadvantage is, of course, it does not break down wet strength. You throw some wet strength paper in and it'll come out just as it went in. And of course, you can only use these in batch mode, not continuous mode. So you have to put the water in, put the fibre in, stir it for a while, empty it, start again. Following a Hydra Pulper, we may often use a deflaker. Deflakers are more often used to report broke, but they can be used to reduce overall energy consumption and processing time. Here's one design of deflaker, and as you can see here and here, you've got pegs sticking out and the pegs interlace like that. So there is a bit of a gap, 2-3 millimetres gap. This is a different design of filling for Hydra Pulper, where these cones sit inside each other, but again, quite a substantial gap, 2 to 4 millimetres gap. The way that deflakers work is they rely on 3 actions. They rely on mechanical impact forces, where the fibres hit these revolving metal parts. They rely on fibre-to-fibre friction, where the fibres rub against each other, or the flakes rub against each other, and the fibres are teased out. And they rely on shear forces. So you've got shear, water travelling one way, water travelling the other way. These hydrodynamic forces will tear apart flakes of fibre and reduce them to individual fibres. This graph is a very telling graph that explains quite clearly the advantages of using a Hydra Pulper followed by a deflaker. If you look at this curve, first of all, this is power consumption. So if you throw in, for example, a sheet of fibre, then it's one giant flake. As it gets torn apart, it becomes smaller and smaller flakes, individual fibres are released, and this curve here is measuring the flake content. So at this point here, where you've just got 1.5% of flake content and everything else has been reduced to individual fibres, it's taken 4 kilowatt hours of energy to reduce 98% of 100 kilos to individual fibres. By using a deflaker, you can reduce this energy considerably. What you would do is load up the Hydra Pulper. When the flake content is down to about 40%, rather than continuing it in the Hydra Pulper, you then empty it and pass it through the deflaker, and it then follows this line. So you've now only used 1.25 kilowatt hours per 100 kilos rather than 4 kilos. So you've reduced the total energy consumption by about 2/3. So a summary of what we've said today. Rotors going into Hydra Pulpers can come from the top, from the bottom, or from the sides. Low consistency pulpers have advantages. Operating continuously will break down wet strength, and they have disadvantages. They damage fibres and they have poor power efficiency. High consistency pulpers, advantages and disadvantages again. The advantages, much more power efficient, no fibre damage, and you get fibrillation, which is helping the refining process. Disadvantages, does not break down wet strength, and it can only be operated in batch mode. The deflakers can save you time and power. And finally, the deflaker action, 3 types of force: shear forces, mechanical impact forces, and fibre-fibre attrition. Thank you for listening to this tutorial, and you can follow us on any of these social media.